to memory. You'll see me box stuff like that in. That's really, really super important. Okay.
Cool.
Now there's a bit more to do here. All right. It's really to the power of 2, really to the power of 2. So there's a rule here that says when you have an exponent to an exponent, you multiply. So you've got to be able to multiply 1/9 times 2. Do you remember how to do that?
Yeah, you have to square it.
You write 2 as 2 over 1, and with a fraction, you multiply the tops, and then you multiply the bottoms. So that becomes 2 over 9. Is that clear?
Yep.
Okay. So this thing right here becomes x to the 2 over 9 power.
Okay.
All right, does that work for you?
Yep.
Okay. Now question 2 is the backwards. You know, math, there's a lot of forward, a lot of backwards. It's figuring out where to put the numbers. So this becomes, and there's 2 possibilities. All right. You have to figure out what goes, I don't know, call it A, and what goes in position B. And if you remember, square root of x is really x to the 1/2 power. There's like a 1 there and a 2 there. Can you tell me in your problem what goes in A and what goes in B?
Okay. A would be 6,
Agreed?
and
And
B
so
would
the
be
other one is,
5. Yeah.
that's right. So that's your final answer. That's what they're looking for there, that part kind of in this box like that.
Okay. Let me write this down. All right.
Got it?
Yep.
Okay. Next question is basically exactly the same. It's negative 4x plus 1. There's a root here. You got to figure out what goes, in A and what goes in B position.
All right. So the A would be 5,
Okay,
and the B would be 4.
that's it. Nothing more, nothing less.
Okay.
All right. Is that okay?
Yeah.
All right. I'm not sensing a lot of excitement. Is it the late hour or is it the math?
Oh, I'm just tired.
Okay. All right. So new problem here, simplify square root of 36, x to e to the 5th, g to the 6th. So there's actually 3 problems in one. It's the square root of 36, it's the square root of e to the 5th, and it's the square root of g to the 6th. Do you know any of those values?
Um, would it be 25?
Square root of 36. What number times itself, you're not
Oh, sure.
squaring, gets you back to 36?
One number to get you back to 36.
Yeah, number times itself. Like, for
Six,
example, like 2 times 2 is 4. That's not big enough. And 12 or 10 times 10 is 100. That's too large. So somewhere in the middle.
6.
That's right. So this is 6. Okay. Now this middle one, make a little more room here so you can see. This middle one is really the square root of e to the 4th times e to the 1. Do you remember why that is true? Like when the bases are the same, what do you do to the exponents?
No.
You add them. So you add 4 and 1.
Mm,
All right. Now, you remember from the previous problem what the square root is in terms of an exponent? It's x to what power when it's the square
Square.
root? 1/2. 1/2.
Um,
So this becomes e to the 4th times e to the 1 to the 1/2 power. Okay. So how does that why does that matter? Well, that 1/2 gets distributed to both of these. So it becomes e squared times e to the 1/2 power. Have I lost you, or is this totally unclear?
let
Or
me
is it
see.
any of this clear?
Um, it's a little confusing.
Yeah. We're kind of jumping into like the harder problems without stepping through the easier ones. So unfortunately, it would appear we really need to get through this, but
Yeah,
um,
we're good. Let's keep going.
okay. So this next one here is g to the 6th to the 1/2 power. When you multiply those, it becomes g to the power of 3. So that becomes 6e squared g to the power of 3, and then this e to the 1/2 is the square root of e. And that is your final answer.
Okay.
Any questions of that before I move to 5?
No.
Okay. All right, number 5 here. Simplify this. So we're kind of going to break this apart. It's the 9th root of x to the 10th times the 9th root of y to the 11th. What does that become? Well, the one on the left here is really the 9th root of x to the 9th times the 9th root of x to the 1. This is another way to break it up. So I'm just trying to show you another. And then this y to the 11th is the 9th root of y to the 9th times the 9th root of y squared. What you should notice here is that the 9 plus the 1 gets you back to 10. The 9 plus the 2 gets you back to 11. Now you might wonder, like, why 9? Why 9? Well, 9 because it matches up with that, what's called the index there. And when those are the same, it simplifies here. So this becomes just x times the 9th root of x to the 1. This 1 underneath here becomes y because it just matches the 9 and the 9 matches. And then it's the 9th root of y squared. So then you piece together the parts that are outside the root, which is x times y, and then the pieces inside the root, x, y squared, 9th root, like that. And that's your final answer. Any questions on that before we proceed?
No.
Okay. All right, number 6 here. This will get a little better from here. So one of the things you should have learned at some point is that to undo the square root, you use a square. And to undo a square, you use a square root. So on the left side, where the variable is, you have a square root. You undo the square root with a square. So on the left-hand side here, the square root goes away. On the right-hand side, it becomes 9 squared. What is 9 squared, Cody?
9 squared is 81.
81, yeah. And so now you're down to what's called a two-step equation, two-step equation. So that is solved by subtracting 78 from both sides. What is 81 minus 78?
3.
3, and then you divide both sides by 3 to get x equals 1.
Alright.
Does that make sense?
Yep.
Okay. I know we're going through this quickly. Hopefully that's okay.
Like the thing is, like he like our math teacher, he like show us like he like made us like check it. Like he did like a check method after. It was weird. That was the thing I
Well,
could.
if you're supposed to check, you should check, but it's basically double the work. Um, we don't have time to get through all these and check it.
Okay, because he'd be like so like there could be like a no real solution on one of them.
Yeah, that's coming. That's coming. None of these so far have had that. All right. Cube root of x minus 8 plus 2 equals -2. You first want to undo this addition by 2 to subtract 2. So this is the cube root of x minus 8 equals -4. All right, now, just like you undo, a square root with a square, you undo a cube root with a cube. So you raise both sides to the power of 3. So that's x minus 8 equals, can you tell me what -4 to the power of 3 is?
Um, it's -64.
-64. Then you add 8 to both sides. What does that become?
It become -56.
Okay, very good. All right, that's your final answer.
Okay. That one was easier.
Yeah, not too bad. All right, we'll keep going here. All right, so next one. Okay, here we go. So it says to solve this, uh, you undo a square root with a square. You're gonna square both sides. On the left, it's 6x plus 16. On the right, it's x squared.
Okay. So would you?
Now you got to get everything on one side. I'm gonna suggest we move everything to the right. And the reason is you really want that x squared to be positive. And then instead of putting 0 equals, you can actually move it over to the right and put equal 0. That way it looks more like what you're used to seeing. Is that okay?
Yeah.
All right, now you're going to factor here. You're trying to find two numbers that multiply to -16, but add to -6.
Um.
Can you think of those numbers?
Let's see. No, maybe like
How about to multiply to just 16?
-8 and 2.
Okay, that works. X minus 8, x plus 2 equals 0. Now you set those both equal to 0. And when you solve it, you get x equals 8, x equals -2. But, it's a big but, you gotta check. You gotta check. So, to check, though, you put them back into the original.
Yeah.
Now, just for like, because we don't have enough time, we're not gonna get through everything. I mean, I assume the goal is to get through everything, right? Or
Mhm.
not. We're just not gonna have time. We'll just cross that one out and not worry about why for the moment. Is that okay?
Yeah.
I don't love that. I mean, that's not my favorite way to do things, but sometimes you just got to get it done. It's like when you're moving, I just got to get that stuff in the truck,
Yeah.
get it on the road. All right, new question for us to look at now. So we're going to first add 14 to both sides. And then we're going to divide by 7. And so this is, I'm just going to slightly write, it's the 4th root of 2x plus 4 equals 2.
Okay.
All right, and then, how do you undo a 4th root based on what we've been talking about?
You gotta put on
What
both
power?
sides.
What power is it this time?
4 all over.
Yeah. So on the left, it just completely undoes it. You get 2x plus 4. On the right, what is 2 to the power of 4?
8.
Try again. It's 2 times 2 times 2 times 2, 4 times.
16.
Yeah, 16. Okay, now I've done a couple of these. Do you want to try solving this from here? This last line, please.
Yeah. I got you. Let's see. So 6.
It is 6. Very good. All right, any questions, thoughts on that before we proceed?
No, that was
Okay,
easy. Question.
I like hearing that. All right, number 10. Okay, so this one's really similar in a lot of ways. We're going to divide by 4. So that's x plus 10 to the 3/2 power. Now, what that really is, it's the square root of this thing cubed equals 8. 32 divided by 4 is 8. How do we undo a square root?
You would multiply on both sides.
What power? What's the exponent?
2
Very
thirds.
good. Just the 2. No, not the 2/3. No to 2/3. That's not the right way to do it. That's wrong. That's bad.
Okay.
Don't do that. All right. Uh, so now it undoes the root, but you still have the power of 3. 8 to the power of 2 is 64.
Okay.
So now how do you, well, I guess we haven't done this yet. So to undo a cube, you use a cube root.
Okay.
And
Square
so
root.
you got to figure out now, like what number times itself 3 times gets you to 64.
Um, I don't know, cause like 21 wouldn't work.
Right,
And
well, that's way too big. I mean, like 1 times 1 times 1 is 1. That's too small. What's 2 times 2 times 2?
eight.
Okay, that's too small. So keep going. Do 3 times 3 times 3 until you find the right number.
Oh, okay. 4.
It's 4. So x plus 10 equals 4. What does x equal?
-6.
Okay, here's your answer. All right, any questions on that?
No.
Okay, let me. All right, I need like 30 seconds to a minute here before we move on to 11. I'll be right back with you. Right back. All right, on to number 11. Number 11 here, which is a graph. We're going to make a table and we're going to graph over here to the right. Okay, do you remember anything about graphing square root functions?
Oh no.
Okay, so there's this really important point, which is -1, 3. The -1 comes from the x plus 1 inside here. When x is -1, what does x plus 1 become?
Um, -2.
Try again. -1 plus 1.
Oh, it'll become 0.
0. So there's certain square roots that you know. You know the square root of 0, you know the square root of 1, you know the square root of 4, you know the square root of 9. Now you don't know all of them, but those are a few that we can start with. So now um, we're going to pick a few more values to put into this in for x. Okay. So I've already done one for you here. So this 0, when you put 0 into this function, you get -3 square root 0 plus 1 plus 3. So order of operation says you start on the inside here. What is 0 plus 1?
1.
Square root of 1 is 1. We can see that over here. -3 times 1 is,
Um, -3.
then plus the 3 gets you to the 0. For this
So,
next point, it's the square root of 3 plus 1 plus 3. Could you try simplifying that for us, please?
yep. Um, 3.
-3.
Ah,
right? Because it becomes 2, -3 times 2 is -6, plus 3 is -3. 8, and the last one here is -3, square root of 8 plus 1 plus 3. Could you try simplifying that for us, please? It is a negative number.
-6.
-6, good. Okay. All right, now we got to plot these points. These are ordered pairs. You just got to plot these points on the graph. -1, 3, 0, 0, 3, -3, 8, -6, like that. In a future lesson, we can talk about why it's going to the right. But for now, let's just go with it.
Yeah.
I don't sense that I'm going to get a lot of resistance from you to. That's okay. It's like diagramming a basketball play. All right, let me know when you get all that down. We'll move to
I got it done.
12. You got it?
Yeah.
Very similar. Very, very similar. We're going to make a table again, and then we'll graph the points. Each of these has like what's called a different parent function. You know, you look like your parents, some combination thereof. Even if you don't think you do, we all kind of look like our parents. So with this one though, it's a little bit different. I mean, they don't all have the same table values, but you're gonna have a center point here, okay? And then we're gonna see how far left and right we can go. So if it's 6, that's going to be okay. And then let's go the other direction. 4. That's probably all we can do. I guess we can go -3. That'll fit on there. And then 12, 13. Does it go up 13? No, that's it. Okay. So let's start with the 6. The 6 is the easier one. It's 3 times the cube root 6 minus 5 plus 2. So just like before, we start on the inside. 6 minus 5 is 1. The cube root of 1 is 1. 3 times 1 is 3, plus 2 is 5. Okay. Then we'll do it for this one down here. 3 times the cube root of 4 minus 5 plus 2. 4 minus 5 is -1. The cube root of -1 is -1. 3 times -1 is -3, plus 2 is -1. And then I think we're able to fit one more point on this graph. This is -8. Cube root of -8 is -2. 3 times -2 is -6. Plus 2 is -4. So get those down in your table. We want to graph this 5, 2, 6, 1, 2, 3, 5. We really do need one more point here to make this graph look correct. So 13 is going to end up being 8, 13, 8. So we really need this third point because it's got to have this kind of this like sideways S shape. You can do a slightly better job of me at connecting the lines, but get the idea, hopefully. All right, take a moment to get all that down before we move to the last problem.
Okay.
You got it. All right. You're motivated to be done. Okay, So just like before, you undo a square root with a square, you end up squaring both sides. So on the left, though, x plus 3 squared really means x plus 3 times x plus 3. On the right, it's 8x plus 24. Do you remember how to FOIL?
Yeah.
Okay. Could you try foiling this on the left for us, please?
Okay, so it would be 9 and x squared and 9.
Okay, that's the first and the last. What about the inner, the O and the I? What about the x times 3? What does that become? That's the O.
Oh, the x and the 3.
Yeah, what does that become?
X cubed.
3x.
Oh, yeah.
And what about the I there, the inner? 3 times the x. What does that become?
3x.
3x, good. And you can typically combine the O and the I. What does 3x plus 3x become?
9x.
Try again. You're adding 3 plus 3.
Oh, 6x.
X squared plus 6x plus 9 equals 8x plus 24. So now you want to move everything left. The reason we want to move it left is that we want x squared to be positive. When you subtract, you want to put those like terms underneath each other. So it ends up being x squared minus 2x minus 15. Now you're looking for two numbers that multiply to minus 15, but add to negative 2. Multiply to negative 15, but they add to negative 2.
-5 and 3.
Yes. X minus 5, x plus 3 equal to 0. So you set each of those equal to 0. And then you solve for x. All right, so it ends up being x equals 5, x equals negative 3. Just like before, we're going to exclude the one of them. We're going to exclude the, actually, we don't have to exclude either of them. That's interesting. These are both good. We don't have to talk about why, just to keep, kind of being,
I kind of how to do the check thing. You just put it back
yeah,
in
you just put
parentheses.
him back in. If it worked, it works.
Yeah,
It's not rocket science. You're just putting the numbers back in, figuring out what it is. Totally doable.
yeah, I can figure it out. I've done
So if you have time, right? If you have time, you should do that on a test or quiz. If you don't, just do the best you can. That's all anybody can ask.
it. Yep.
At least that's how I think about things. All right, we got a little time left here. Is there anything else you would like us to work on tonight?
Mm, no.
Okay. I do apologize for the delay. I do appreciate being flexible with me. So, you sure good on everything for tonight?
Yeah.
All right.